Today we're going to cover just notes over target 3, and we're still going to be looking at those radical functions. So we're solving square root functions. When we do this, our goal is to get the x by itself, and in order to undo a square root, we're going to end up squaring both sides. But one thing that we are going to have to think about when we solve these equations is we have the possibility for an extraneous solution. So as a reminder, extraneous solutions came up last unit, and they were values that made your denominator equal to 0 when you looked at the original function. So here, we're going to have extraneous solutions that do not make sense when we plug them back in to the problem at the very end. So kind of like when we're checking our answers. So I will show you what that all looks like, but starting off with how do you solve a square root equation? So in order to undo a square root, you're going to square both sides. So that's going to lift the radical off of the left side, and then 3 squared is 9. So really basic equation here. So we have x equals 9. However, we do need to make sure we always check our answers. And so to check it, we plug it back in. So the square root of 9, does that equal 3? That's a true statement, nothing wrong with it. So there are no extraneous solutions. Every single time you're going to notice that I plug that answer back in to check my work. So on B, again, a little bit more going on, but to get rid of this square root, we're going to square both sides. That lifts the radical off of the left-hand side, and then 6 squared is 36. And then we're going to continue our solving process from here, so I'm going to subtract 16. So 2x equals 20. And then I'm going to divide by 2, and I get x equals 10. In order to be able to say that that's my final answer, I do need to first check my work, make sure it's not extraneous, there's nothing strange going on. So I'm going to plug it back into that original equation. So 2 times 10 plus 16 equals 6. So 2 times 10 is 20, plus 16 is 36. The square root of 36 is 6. So that comes out just fine, so that means 10 is our solution on B. Continuing on C, what makes C a little bit different is that you have a -5 in front of the square root, and so before we get rid of the square root, we actually have to get rid of that -5. So I'm going to divide both sides by -5. That leaves us with the square root of 2 minus x equals 3. Now to get rid of the square root, I'm going to square both sides. 2 minus x equals 9. Continuing solving by subtracting 2. So -x equals 7. Getting rid of that negative out in front, and we get x equals -7. Again, part of your process to solve has to be to check your work. This is no longer an optional step. On target 3, you do have to check your work. So I have a -5 square root of 2 minus -7. So when you subtract a negative, that would become a plus equals -15. So this is -5 times the square root of 9 equals -15. The square root of 9 is just, the square root of 9 is just 3. And so we can see that this is a true statement. Moving on to D. So very similar to C, if you notice that -6 is outside the square root, so we've got to get rid of that first. So I'm going to add the 6 to the other side. And then I'm going to square both sides. 9 squared is 81. And then using my solving skills, so subtract 1 and divide by 10. So I got 8 equals x. And then I'm going to check my work by plugging it back into the original equation. So that would be 3 equals the square root of 10 times 8 plus 1 minus 6. So 10 times 8 is 80 plus 1 is 81. and the square root of 81 is just 9. So 3 equals 9 minus 6, which is a true statement. So we did not find any extraneous solutions on the front, so everything came out just exactly as we expected it to in terms of checking our answers. Moving on to the back, on E, we have the square root already isolated, so I'm going to start by squaring both sides. However, when you square the left-hand side, you're going to actually have to square the whole thing, which means we actually have x minus 6 times x minus 6 equals 3x. And then I have to FOIL those together. I have to multiply those together. So I would get x squared minus 6x minus 6x plus 36 equals 3x. So combining those like terms, I actually have x squared minus 12x plus 36 equals 3x. And if you notice, this is a quadratic, which means it has to be equal to 0 to solve. So I have x squared minus 15x plus 36. And I'm going to choose to factor to solve this. So numbers that multiply to 36 and add to negative 15. That would be 3 and 12. So negative 3 and negative 12. And so we can use the shortcut here, so go straight to our factors. So x minus 3 and x minus 12. So our solutions, or possible solutions, would be x equals 3 and x equals 12. We do have to check both of those answers. So I'm going to start with x equals 3, and I'm going to check that. So let me remind myself what the original problem was. So x minus 6. So if I plug in a 3, that would be 3 minus 6 equals the square root of 3 times 3. Just plugging in the 3 for both of those x's. So this would be negative 3 equals the square root of 9. That's actually a false statement. The square root of 9 is positive 3. So that is not a solution. Now I'm going to check x equals 12. So 12 minus 6 equals the square root of 3 times 12. So this is 6 equals the square root of 36. That is a true statement, so we're going to leave x equals 12 as our only solution to that problem. On F, thinking about what we would have to do to start off with, to get rid of your square root, you're going to square both sides. So we have a case that's very similar to what we did on E, meaning that on the left-hand side, the square root just lifts off. And on the right-hand side, we have x plus 5 times x plus 5, so we're going to have to multiply that together. So that would be x squared plus 5x plus 5x plus 25. I'm going to go ahead and combine my like terms. 5x plus 5x is 10x. And now I'm going to set this equal to 0. So I'm going to subtract the 21x. And I'm going to actually go ahead and subtract the 1 as well. So we just have 0 on this side. That would be x squared minus 11x plus 24. Oh, I already have the equal 0. Don't need to. And so factoring this, so numbers that multiply to 24 and add to negative 11, those numbers would be negative 8 and negative 3. I can use the shortcut, so going straight to the factors, my factors would be x minus 8 and x minus 3, and the solutions would be positive 8 and positive 3. As we saw in the last problem, before we can for sure say that those are our two answers, we do have to check them with our original problem. So I'm going to start with x equals 8. So the square root of 21 times 8 plus 1 and that should equal 8 plus 5. So 21 times 8 would be 168, plus 1 is 169, equals 13, and the square root of 169 is 13. So that's a true statement. Let's check out 3. So the square root of 21 times 3 plus 1 equals 3 plus 5. So the square root of 21 times 3, so 21 times 3 is 63, plus 1 is 64, and the square root of 64 is 8. So in this case, both answers actually worked. So it's not a situation where you have like two answers and one always works and one doesn't. It's really something that's unique to each problem and you have to check every time. All right. So the thing that makes our last two problems unique is that it's a square root equal to a square root. And so thinking about what we did in the previous problems, we would just square both sides in order to get rid of that square root. And that actually just lifts off the square root from both sides. It's almost one of the easiest cases. It just looks the most complicated. So now I'm combining my like terms. So I have 3x minus 5 equals 7. I'm going to add 5. So I have 3x equals 12. I divide by 3. I get x equals 4. And as we've learned, we are going to have to check our answers. So I have the square root of 4 times 4 minus 5, and that should equal the square root of 4 plus 7. So we'll see if it does. So 4 times 4 is 16, minus 5 is 11. So we have the square root of 11 is equal to the square root of 11. That's a true statement. Square root of 11 is a decimal, but it is equal to itself. Last problem on your notes here, very similar to G in that we're going to start by squaring both sides. It lifts off the square root. And so now we're just solving. So I'm going to subtract 3, and I get x equals negative 10. All right, I'm going to go ahead and plug this in to the original problem to check my work. So that would be the square root of negative 10 minus 7 equals the square root of 2 times negative 10 plus 3. So this is the square root of negative 17 equals the square root of 2 times negative 10 is negative 20 plus 3 is negative 17. So at first this looks like it would be a true statement. However, the negative under the square root means that there's no real solution. Remember, if you have a negative under your square root, that's an I scenario, which means this is not actually a solution, and we say no solution. So two situations can happen. The first thing can happen is that when you plug it back in, you get a negative under the square root, like we did here on H. You throw out your answer and it's no solution, or if you had two answers, it's just the other one. The other thing that happens is over here on E, when we plugged in the 3, it actually just made a false statement. So if it makes a false statement, you also throw that solution out. So that is all the different scenarios that you could come across on target 3 solving a square root equation.